Hello and welcome to Math with Mrs. Becker. Today in Algebra 2 we are going to prepare for our second quiz for Chapter 5. Now this quiz will cover the sections 5.4, 5.5, and 5.6. Let's get started. So section 5.4 was all in a process called completing the square. Now as I instructed you in section 5.4, oftentimes when we were completing the square I referred to it as finding the magic number. And the reason why is because if I have two terms, I have a squared variable and a single variable, what you're doing when you're completing the square is finding a number that I could add to make it a third term where I will be able to factor using what's called a perfect square trinomial. And what that means is there will be two numbers, they will be the same number that multiply to the third number and add to the middle. So here's how this works. You have to make sure you do not have a number in front of your squared term, and we do not. So what I have to do is take the value that they call b. That's the number in front of x. It's b divided by 2, and then you square it. Now notice I do have parentheses here. Order of operations will have to do what's in the parentheses first. 4 divided by 2 is 2. 2 squared is 4. So what happens is your missing number is 4, and that's what I called the magic number. So it says find the missing number and factor. Now remember, the reason why we're doing this is so that way we can factor it. Find two numbers that multiply to 4, and if you take the same two numbers and you add them, you get 4. Well, that happens to be 2 and 2. So we would write that in factored form as x plus 2 quantity squared. Here's another one. If I want to find the third term, make sure there is not a number in front of your x squared. We do not have that. Take b, negative 8, divide it by 2, then you square it. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So 16 is the missing number. Now what you're doing is you're doing the multiply add method of factoring. You're trying to find two numbers that multiply to 16. The same two numbers add to negative 8. Now again, as a little shortcut, if this is something that you struggle with, what you can do is look at the value that's in parentheses prior to you squaring it, okay? So if I want to know the value of this, I would take negative 8 divided by 2. So that's a negative 4. So factoring it will be that negative 4. So I have negative 4 times negative 4. Yep, that's 16. Negative 4 plus another negative 4 is negative 8. One more like this. If I want to find the missing number and factor, you take b, in this case it's 12, you divide it by 2 and you square it. 12 divided by 2 is 6. 6 squared is 36. Now I'm doing the multiply add method. I need two numbers that multiply to the last term, which is 36. Same two numbers have to add to the middle, which is 12. The numbers that will work, it's always going to be the value that's in the parentheses before you square it. 12 divided by 2 is 6. So x plus 6 quantity squared. This tells us that the number was a positive 6. 6 times 6 is 36. 6 plus 6 is 12. So that's the first thing that you will see on the quiz. Find the magic number and then factor. Now what that does is it leads us into the whole process called completing the square. Completing the square allows us to solve a quadratic. And remember, solving means if you were to graph the parabola, where would it touch the x-axis? So when we are doing the complete the square process, step 1, you want your letters on one side and your numbers on the other. We have that. Step 2, you cannot have a number other than 1 in front of your squared term. We're good to go. So step 3, we find the magic number. I take 10, divide it by 2, and I square it. 10 divided by 2 is 5. 5 squared is 25. So 25 is the number that I can add so I can factor the side. But now we transition from just looking at two terms to looking at a full equation. And what we've learned with equations is what you do to one side, you must always do to the other. So not only does this 25 become the third term on the left side, I also have to add the 25 here. So 25 plus the 20 that was already there is 45. Once you have three terms right here, what you're doing is factoring. I need two numbers that are the same number, that if I multiply them, I get 25. If I add them, I get 10. That's 5 and 5. 5 times 5 is 25. 5 plus 5 is 10. Now we cancel the power of 2. When you cancel a power of 2, what you're doing is taking the square root of each side. Square root cancels a square, leaving me x plus 5. Anytime you cancel a power of 2, you need to include both a positive and a negative. 45 is not perfect, so what we have to do is use a factor tree to break it down. 45 can be created from 3 times 15. 15 can be created from 3 times 5. Anytime you can cross off two numbers that match, you get to write it on the outside once. 5 cannot be crossed off, so 5 is still stuck underneath the radical. Now our last step, because it says to solve. You're not done until the letter's by itself. On the same side of the equation as x, I have a plus 5. I need to take that plus 5 and move it to the other side. And when you move it, it comes in front of the plus or minus symbol. So x equals negative 5 plus or minus 3 square roots of 5. This is actually two answers. One answer is negative 5 plus 3 square roots of 5. The other answer is negative 5 minus 3 square roots of 5. Okay, let's look at a couple more just because I know this is kind of a lengthy process. So looking at number 2, step 1, I need my letters on one side and my numbers on the other. So I need to first take this negative 14x, add it over so it's on the same side as my x squared. This positive 13 does not have a letter, so if it's just a number, it needs to go on the right side. So my x squared gets to stay. Negative 14x is jumping over the equal sign. It's negative here, so to go to the other side, it would change signs and now it becomes a positive 14x. This is a positive 13. To move it to the other side of the equation, I would be minusing 13. That's step 1, letters on one side, numbers on the other. Step 2, make sure we do not have a number in front of the square term. We don't, so I can find the magic number. Take b, whatever is in front of x, divide it by 2 and square it. 14 divided by 2 is 7, and 7 squared is 49. So 49 is the number that if I add it to both sides, I will be able to factor this and solve. X squared plus 14x plus 49. This side I had a negative 13. If I had negative 13 and I add 49, now I have 36. Once you have three terms here, what we have to do is factor. Two numbers that multiply to 49 and add to 14, well, that's 7 and 7. So I write that as x plus 7 squared. Now we cancel the power of 2. To cancel the power of 2, I have to take the square root of each side. A square root will cancel a square. X plus 7 equals. Anytime you cancel the power of 2, we must include both a positive and a negative. The square root of 36 is 6. Last step, if I'm trying to solve for x, on the same side of the equation as x is plus 7. So I need to minus that 7 to the other side. It will look like this. X equals negative 7 plus or minus 6. Now here, I can go further. I do not have square roots, so in order to find my solutions, I simply add the two numbers and subtract them. Negative 7 plus 6 is a negative 1. Negative 7 minus 6 is a negative 13. Those would be the two solutions. So what this means is if I were to enter this into Desmos.com and look at that parabola, it would cross the x-axis 1 unit to the left of the origin and 13 units to the left of the origin. One more, complete the square problem. Step 1. What I want to do is have my letters on one side and my numbers on the other. So this negative 12x does need to move over on the same side as x squared. For x squared, it's a negative 12x here, so I need to add it. Equals what I have remaining is 4. So that is step 1. Letters on one side, numbers on the other. Next step, we cannot have a number in front of our squared term. Currently, we have a 4. The way that you get rid of that is you divide every single term by whatever number's here. So the 4 cancels, leaving me x squared. 12x divided by 4 is 3x. 4 divided by 4 is 1. Now it's time to find the magic number. So I take b, divide it by 2, and I square it. Well, this time, 3 divided by 2, that does not divide perfectly. We are not allowed to go into decimals, so at this point I leave it in fraction form. In order to apply the power of 2, you square both the numerator and the denominator. 3 squared is 9, 2 squared is 4. So my magic number that I need to add to both sides is 9/4. Here it's x squared plus 3x plus 9/4 equals, I had a 1, I need to add 9/4 to it. You can only add fractions if you have a common denominator. 1 is the same thing as 1 over 1. So in order to get this denominator to match a 4, I would need to multiply both top and bottom by 4. So this becomes 4 over 4. Now when you're adding the fractions, the common denominator stays. What you're actually adding is the numerator. 4 plus 9 is 13. Now it's time to factor. Two numbers that multiply to 9/4 and add to 3. Again, especially when it is a fraction, don't waste too much time trying to figure it out. 100% of the time, it will be whatever was inside of the parentheses before you took it to the power of 2. So in this case, it's a positive 3/2. So it's x plus 3/2 of the power of 2 equals 13 over 4. Now I need to cancel the power of 2. You do that by taking the square root of each side. Square root cancels a square. X plus 3/2 is what I'd have left. If I cancel a power of 2, it's plus or minus. When you take the square root of a fraction, what you're doing is taking the square root of the top and the bottom separately. 13 is a prime number. I cannot break it down. It's not a perfect square root, so that remains the square root of 13. Square root of the bottom, square root of 4 is 2. Last step, I need to get x all by itself, so I need to move my plus 3/2. The way to move a positive is to subtract it. X equals negative 3/2 plus or minus a square root of 13 over 2. That is completing the square. Done with page 1, and we are done with section 4.4. Now 5.5 is the introduction to imaginary numbers. Now I, by definition, is the square root of a negative 1. What that tells us is anytime you see a negative underneath a radical, we are going to have a final solution that is imaginary. So here's how we can simplify these. So I have a 3. If you see a negative underneath the radical, you pull out the negative 1. What that does is it now changes that 49 into a positive. That would be step 1. Step 2, we go ahead and simplify each. There's nothing I can do with the 3. The square root of a negative 1 by definition is I. The square root of 49 is 7. Now your solution is the product of these items. 3 times 7 is 21, so it's an imaginary 21. Let's do a couple more. I have 2. There's a negative, so I pull out a negative 1. That leaves the 20 now to be positive. 2 cannot be simplified. The square root of negative 1 is I. 20 is not perfect. So if it's not perfect, we need to be comfortable with making factor trees. 20 is 2 times 10. 10 is 2 times 5. I can cross off 2 2's. That allows me to write a 2 on the outside. 5 cannot be crossed off, so that's stuck underneath. So my solution is the product of these 3 items. Now the rule is you cannot multiply something underneath the radical unless it too is underneath the radical. I don't have any other square root symbols, so this 5 is going to stay the same. What I'm multiplying are the numbers that are not underneath a square root. 2 times 2 is 4 times I, so it's an 4I, it's imaginary. The square root of 5 is still in the answer, it just goes unchanged. One more like this. If I have a negative underneath the radical, you pull out the negative 1, that makes it a positive 18. Square root of negative 1 by definition is I. 18 is not perfect, so I break it down. 18 can be created by 2 times 9. 9 is 3 times 3. I can cross off 2 3's. That allows me to write a 3 on the outside. 2 cannot be crossed off, so 2 is left on the inside. I multiplied these two things together. Because the I is not underneath a square root symbol, the I can only be multiplied to the 3. So I times 3 is 3I times the square root of 2. So that's how you can change functions or expressions that have a negative underneath the radical, and you can rewrite it as a term that has an I in it. Okay, now this takes us to a whole new step. These are problems that if you would have previously tried to solve, you try to get the letter by itself, you would have had to write no solution or undefined. But now, if we have something that is not real, we can go ahead and find an imaginary answer. So we are going to solve the equation. Remember, solve means that you are getting the letter all by itself. So on the same side of the equation as x, but not touching, is a minus 81. Or sorry, a positive 81. What I need to do is minus it to the other side. Positive 81, negative 81 cancels. So I have 3x squared equals 0 minus 81 is a negative 81. If I'm trying to get x by itself, I need to cancel that 3. Right now it's 3 times x squared, so in order to undo the multiplication, I divide. That leaves me with x squared equals negative divided by a positive is a negative. 81 divided by 3 is 27. Now in order to cancel a power of 2, you take the square root of each side. Square root cancels a square, so x is alone. I cancel the power of 2, so it's plus or minus. Now this is what we just practiced. There is a negative underneath, so what I can do is pull out the negative 1. What that does is it makes the 27 positive. The square root of a negative 1 is I. 27 is 3 times 9. 9 is 3 times 3. I can cross off 2 3's. That allows me to write 1 3 on the outside. This 3 cannot be crossed off, so it's stuck on the inside. So my solution is what I get when I multiply these two things together. The I and the outside 3 can get multiplied because they are not underneath a radical. I times 3 is 3i, and then it's connected to the square root of 3. The reason why I have a plus or minus here is because in the process, I canceled the power of 2. Here's another one. If I'm trying to solve, on the same side of the equation as the variable, as I have a 4. This 4 is currently being multiplied by x squared. To undo multiplication, we divide. What you do to one side, you do to the other side. X squared is now by itself. Negative divided by a positive is a negative. 28 divided by 4 is 7. To cancel a power of 2, I take the square root of each side. Square root cancels a square, x equals. I cancel the power of 2, so it's plus or minus. There's a negative underneath, so I pull out the negative 1. That makes the 7 positive. The square root of a negative 1 by definition is I. Now 7 is not a perfect square root. 7 cannot be broke down, so it remains the square root of 7. So this is an imaginary square root of 7. That would be your solution. Last one like this. If I want to solve for x, on the same side of the equation as x but not touching is a plus 12. To cancel a plus 12, I minus 12. So 1/2 x squared equals 0 minus 12 is a negative 12. Now, I remember in math, you cannot divide fractions. Okay, so I can't divide both sides by 1/2. What you do instead is multiply by the reciprocal. The reciprocal of 1/2 is 2 over 1, which is just 2. Now what happens here, 1/2 of 2 is just 1. So 1 times x squared gets me down to x squared. Negative 12 times 2 is a negative 24. I need to cancel the power of 2, so I take the square root of each side. The square root cancels the square. X is now isolated. I cancel the power of 2, so I need to include both the positive and negative. There is a negative underneath the radical, so what I do is pull out that negative 1. That makes the 24 positive. The square root of a negative 1 means that this term, this solution, is going to be imaginary. 24 is not perfect, so I break it down. 24 is 6 times 4. 4 is 2 times 2. 6 is 2 times 3. So I can cross off 2 2's. That allows me to write a 2. It is imaginary, so it's 2i. 2 and 3, because they cannot be crossed off, they are stuck underneath. I have more than one term stuck. In order to turn them into one value, you multiply them. 2 times 3 is 6. So there are 3 examples of how you solve equations that have imaginary solutions by using square roots. You can also complete the square like we did on the front side of the review, but sometimes your solutions are going to be imaginary, and that's what we're going to see right now. If I am finding the zeros, anytime they ask you to find the zeros, your first step is you want to make sure that your equation is set equal to 0. They want us to complete the square. Step 1, letters go on one side, numbers go on the other. So my first step after putting in that 0 is I need to minus the 4 to the other side. Next, I look. I do not have a number in front of my square term, so I can go ahead and find the magic number that's going to make this thing all work. I take b divided by 2 and I square it. Negative 2 divided by 2 is negative 1. Negative 1 squared is a positive 1. So what I need to do is add 1 to each side. This side becomes x squared minus 2x plus 1. If I had negative 4 and I add 1 to it, now it's a negative 3. Once I have 3 terms here, what I can do is factor two numbers that if I multiply them, I get positive 1. If I add them, I get negative 2. And it's always whatever I have in the parentheses before the power of 2. So negative 2 divided by 2 is a negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is a negative 2. So I can factor it in this format. Now I cancel the power of 2 by taking the square root of each side. Square root cancels a square. X minus 1 equals. I cancel the power of 2. That's where I get my plus or minus. There's a negative underneath the radical, so I go ahead and pull out the negative 1. This means that my solution is imaginary. Square root of 3, I cannot simplify it, so it's plus or minus an imaginary square root of 3. Last step, I need to move this minus 1. In order to move a negative 1, I add it over. So x would equal a positive 1 plus or minus an imaginary square root of 3. Last one like this. Again, we are finding zeros, which means where the parabola crosses the x-axis using the complete the square method. Because I'm finding zeros, I take the original equation and I have to set it equal to 0. Now I want my letters on one side and my numbers on the other. Negative 2x squared plus 8x equals, now it's a positive 16 on this side. It was negative here. When you move it over to the other side of the equation, the sign switches. I am not allowed to have anything in front of the squared term, so I need to cancel the negative 2. The way that we cancel it is we divide it by every single term. The negative cancels, the 2 cancels, so I have x squared. Positive divided by a negative is a negative. 8 divided by 2 is 4. It's connected to an x. Positive divided by a negative is a negative. 16 divided by 2 is 8. I no longer have a number in front of my square term, so I can find the magic number. I take b, which is negative 4, divided by 2, and I square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So 4 needs to be added to both sides. X squared minus 4x plus 4 equals, if I had negative 8 and I add 4 to it, now it's a negative 4. Time to factor. Two numbers that multiply to positive 4 and add to negative 4 are negative 2 and negative 2. So I write it as x minus 2 quantity squared equals a negative 4. To cancel the power of 2, you take the square root of each side. Square root cancels a square. X minus 2 equals, I cancel the power of 2, so I need to include both the positive and negative. There's a negative underneath the radical, so I pull out the negative 1. That would make the 4 positive. The square root of a negative 1 means that this is imaginary. The square root of 4 is 2. If I take 2 times I, it becomes 2i. Last step, if I want x by itself, I need to take this minus 2 and add it over. When I add it over, it comes before the plus or minus. So my final answer, x would be alone. Because I added the 2 over, it's now a positive 2, plus or minus 2i. There are 2 examples of completing the square where your solution is what's called a complex number. You have a real portion and an imaginary portion. One thing to make sure that you realize is that the real portion comes first. Turn page. So now that we've looked at complex numbers, You can have two complex numbers with an equal in between them, and by taking what's real and setting them equal, and by taking what's imaginary and setting them equal, you can create equations and solve for variables. So let's do that. So if I want to solve for x and y, I need to look at this side and say, okay, what is real? Anything real is not connected to an I. So 2x is real. This is imaginary because it's connected to an I. There's nothing left real on this side, so I put the equal sign to say, okay, I'm going to the other side. On this side, what is real, what doesn't have an I, is the 8. This is an equation that I can solve. Go ahead and divide both sides by 2. 8 divided by 2 is 4. Now we do the same thing with imaginaries. So on this side, what is connected to the I? Negative 20. Notice I don't write the I. I just state what is connected. I'm going to the other side, equals. What is connected to the I? Negative 4y. And again, another reminder, if you have a minus sign, it's always stuck with whatever's behind it. So this minus has to stay with the 4y. Now to get y by itself, divide both sides by negative 4. Negative divided by a negative is a positive. 20 divided by 4 is 5. So y is 5. Here's one more like that. You look at each side, what is real? 6x is real because it does not contain an I. Equals, you go to the other side. On this side, positive 10 is real. This is an equation. To solve for x, I need to divide both sides by 6. 10 divided by 6, I can reduce it by dividing both top and bottom by 2. So my solution is the fraction 5/3. Now, if you went ahead and did 10 divided by 6 and wrote it in decimal form, you're totally fine. I would accept that answer as well. Okay, now if we look at what's imaginary, negative 2 is imaginary because it's connected to an I. Equals negative 2y is imaginary because it's connected to I on the other side. If I want y all by itself, I need to get rid of the negative 2 that right now is being multiplied. That's why I'm dividing it. Negative divided by a negative is a positive. 2 divided by 2 is 1, so y is 1. So those two are examples of how you can use complex numbers that have an equal in between them to create equations and solve for variables. Now, complex numbers always come with what's called a conjugate. You cannot have just one solution. They come in pairs. Now, a conjugate means that you have the real number first and the imaginary number second. The real number and the imaginary number stay the same. The only thing that changes is the sign in between them. And that's because of that plus or minus sign that we saw as we were completing the square a little bit ago with our real numbers and our imaginary numbers. So here's an example. If I have 5 plus 3i, our complex conjugate is 5 minus 3i. Keep the 5 the same, keep the 3i the same. The only thing that changes is the sign in the middle. If I have the square root of 5 minus 4i, your conjugate is the square root of 5 plus 4i. Square root of 5 stays, 4i stays, you change the sign in the middle. Now here we have a problem. Notice that the imaginary part comes first. You always need the real part to come first. So 13 must come before the 6i. So 13 plus 6i, now I can find the conjugate, which would be 13 minus 6i. Number 4, we have a little problem as well. Complex. A complex number means you have two parts, a real part and an imaginary part. This says 7i. What that means is that it's only imaginary. I need to add a real part. So I have to go 0 plus 7i. 0 is real, 7 is imaginary. The conjugate of 0 plus 7i is 0 minus 7i. That is the conclusion of 5.5. Now 5.6 is what we looked at yesterday. It is the quadratic formula. Now underneath the square root of the quadratic formula, you have a formula for what's called the discriminant. The discriminant tells you the number of solutions you're going to have and the type. The type means are they real or are they imaginary. The formula is b squared minus 4ac. Anytime you're working with the quadratic formula, you need everything in this format. ax squared plus bx plus c equals 0. You always want to make sure it's equal to 0. And then you go from the most amount of x's to the least. 2 x's, 1 x's, no x's. That way you could state your a, your b, and your c. So the first two examples, we are just finding the discriminant, okay? We're not doing the whole process. You want it set equal to 0 first, so I'm going to take this minus 8 and add it over. So I'd have x squared minus 3x plus 8 equals 0. 2x's, 1x's, no x's. A is the number in front of your squared term. In this case, it's an unwritten 1. B is the number in front of x. It's a negative 3. C is the number at the end. It's 8. So I'm filling in this formula. B is negative 3 squared minus 4 times A is a 1. C is an 8. You have to be careful to enter it into your calculator just like we wrote it with the parentheses and everything. So if I have negative 3 in parentheses to the power of 2 minus 4 times 1 times 8, we would get negative 23. This number is called your discriminant. If your discriminant is negative, you have two non-real solutions. What that means is my solutions, I have two of them because of the plus or minus sign. They are not real, meaning that they will have an imaginary. They will have that I. Let's do another one. I need it equal to 0, so I have to take this negative 6x and add it over. But it's important to put it in the correct location. 2x's, 1x's, no x's. So this negative 6x, because it has an x, has to go in between these two terms. I would have x squared. It's negative here, so when I bop it on over to the other side of the equation, this becomes positive 6x. Minus 3 equals 0. Once it's equal to 0, we can identify what is A, what is B, what is C. A is the number in front of the square term. It's a 1. B is the number in front of your single variable. It's a 6. C is the number at the end. So now to find my discriminant, I fill in B squared minus 4AC. B is a 6 squared minus 4 times A is a 1. C is a negative 3. Fill that into your calculator. Careful with the parentheses. And our discriminant is 48. This is a positive value. If your discriminant is positive, you have two real solutions. So again, the reason why it's 2 is because of the plus or minus. These are real, meaning your final answer will not contain an I. Now the last thing that you'll see on the quiz is actually finding the zeros using the quadratic formula. So this is the first step. Then we just go ahead and we find those solutions. This time it's set equal to 0. A equals, B equals, C equals. A is always the number in front of your squared term. It's a 2. B is the number in front of x. It's a negative 5. C is the number at the end. It's a 3. So B squared minus 4 times A times C. This gives me the number that goes underneath the radical, underneath that square root symbol. And I end up with 1. This is positive, so my final solution, I should have two real solutions. So x equals negative b. B is a negative 5. Negative of a negative makes it a positive 5. Plus or minus the square root. That's where this comes into play. The number you just calculated goes underneath the radical. All over 2a. A is a 2. So I have to take 2 times 2, and I get a 4. Your next step is you look at your radical, and you see if there's anything we can do, as in simplify it, anything like that. The nice thing is this is perfect. Square root of 1 is 1. So I can find my two solutions. I add the two numbers on the top, divide them by 4. Subtract the two numbers on the top, divide by 4. So 5 plus 1 is 6. 6 divided by 4, I can reduce both of them by dividing by 2, and I'd have 3 halves. Or if you just took 6 divided by 4, you get 1.5. Now I subtract. 5 minus 1 is 4. 4 divided by 4 is 1. So our two real solutions are 3 halves and 1. Two more examples like this just to make sure, and that's everything that you will see on the quiz. This is already set equal to 0. A, B, C. A is the number in front of your square term. B is the number in front of your single variable. C is the number at the end. Now what I fill in is B squared minus 4 times A times C. So I go ahead, be really careful with the parentheses. Negative 10 squared minus 4 times 3 times 4. I got 52. So now this is a positive number. So I know I am looking for two real solutions. Now we find those solutions. X equals negative b. B is a negative 10, so I use a positive 10. Plus or minus the square root. This 52 that we already calculated is what goes underneath. All over 2a. A is a 3. 2 times 3 is 6. Your next step is to look at the radical and see if there's anything we can do. 52 is not perfect, so I see if I can break it down. 52 is 2 times 26. 26 is 2 times 13. So I can simplify it. 10 plus or minus. I can cross off two 2's. That allows me to write a 2. 13 cannot be crossed off, so it stays underneath. And there's a 6 in the bottom. Last step. You look at the numbers that are not underneath the radical. You see if they are divisible by the same number. 10, 2, and 6 are all divisible by 2. So I can simplify this by dividing every single number besides the 13 by 2. 10 divided by 2 is 5, plus or minus. 2 divided by 2 is 1. So it's 1 square root of 13. You can write the 1 if you want, or 1 is allowed to be unwritten. 6 divided by 2 is 3. Here are your two real solutions. The reason why it's 2 is because one answer is 5 plus the square root of 13 over 3. The other solution is 5 minus the square root of 13 over 3. Last question of the review. Step 1, you want to make sure it's equal to 0. So I first have to take the minus 1 and I add it over. Once it's equal to 0 and it's in the right order, 2x's, 1x's, no x's, you are ready to state A, B, and C. A is the number in front of your squared term. B is the number in front of x. C is the number at the end. Next, we calculate the discriminant. B squared minus 4 times A times C. Now, this is the number that's going to go underneath the radical symbol, that square root symbol. If you calculate it all up, I ended up with 1. So x equals negative b. B is a positive 3, so in the formula it's a negative 3. Plus or minus the square root. B squared minus 4ac, that goes underneath the radical. All over 2a. A is a 2, 2 times 2 is 4. Next step, you see if you can simplify this. The square root of 1 is 1. Negative 3 plus or minus 1 over 4. Now I can find my two answers. This does not contain a square root, so I go ahead and calculate. Negative 3 plus 1 is a negative 2. Negative 2 over 4 can be reduced to negative 1/2. Negative 3 minus 1 is a negative 4. Negative 4 divided by 4 is a negative 1. Now this was a pretty good review. I think I went over every concept that we covered in 5.4, 5.5, and 5.6. This is going to help you huge when it comes time for the quiz. Just please make sure that you take some time to look it over so you're comfortable with the material. Thank you for joining me today, and I'll talk to you soon.